Consider a disk with size 40 GB. We need 16 bits to address disk blocks of size 4 KB. Number of blocks need to keep track of free space if the disk is initially empty by using bitmap method. Here, size of the disk is given as capacity of the disk. Capacity is 40 GB. And 16 bits, we need 16 bits to address disk blocks of size 4 KB. That means disk block size is given as disk block size is given as 4 KB, and 16 bits are needed in order to address the disk blocks. That means disk block address size is given as 16 bits. That means that is equal to 2 bytes. So this is the given information. Here the question is, we have to find the number of blocks needed in order to keep track of the free space by using bitmap method. There are two methods by which we can use for managing free space. They are bitmap method and free list approach. In bitmap method, we need, for each and every block, we need 1 bit. That means if it is not free, it will be denoted by 1, and if it is free, it is denoted by 0. So here now we have to calculate total number of blocks in the, here it is given that the disk is empty, initially empty. So here the number of blocks in the disk is number of blocks is equal to total size. Total size is 40 GB. 40 2 power 30 bytes by disk block size. Disk block size is 4 KB. 4 into 2 power 10. So this is 10, and 10 into 2 power 20 blocks. This is number of blocks in the disk. So we got 10 mega blocks. We got 10 mega blocks in the disk, and they are empty, initially empty. That means we need, as we are using bitmap method, we need 10 megabits in order to maintain the free space. So here for each and every block we need 1 bit in bitmap method. As the number of blocks is 10 mega blocks, we need 10 megabits. So 10 megabits number of blocks needed to accommodate these 10 megabits. So block size is, so number of blocks for keeping track of free space using bitmap method. Here we have 10 mega blocks, so we need 10 megabits. 10 into 2 power 20 by block size is 4. Block size is 4 KB. Here 4 into 2 power 10. Let us convert this into bits. So if we convert this, we have to multiply by 8. So this is a number of blocks. So if we simplify this, we'd be getting 320 blocks. So which is option? Here given options are, let me write the options. Option A is given as 2560. Option B 5120. Option C 1280. Option D none. We got as answer as 320 blocks. So here D none of these is the answer. Consider the relation R with attributes x, y and z. Here attributes are x, y and z, and if this set is given as x, y gives z and z gives x. The highest normal form of the relation R is 1NF, 2NF, 3NF and BCNF. In order to solve these kind of problems, we have to find the key for the given relation by using FD set. Now let us find key for the given set. Here if we find XY closure begetting X, Y and Z, as X is derived from Z, we can substitute Z in place of X in the key. As XY derives all the attributes, XY is one of the keys and X can be derived from Z. So we can substitute Z in place of X in the key. So this will become ZY. So the keys are XY and ZY. These are the keys for the given relation. Once we find keys, we have to look for the partial dependency, or we have to check if that table contains any partial dependencies or transitive dependencies. Here the key attributes are x, y and z. So when all the attributes of the table are key attributes, then we can simply say that relation will be in 3 up to 3NF. Why? Because there will not be any partial dependencies. Why? Because partial dependency means part of the key to some non-key attribute. As all the given keys, all the attributes are key attributes, there will not be any non-key attributes. So there will not be any partial dependencies in the given relation. If there are no partial dependencies, we can say that table is in 2NF. Now let us check for 3NF. 3NF means there should not be any transitive dependencies. Transitive dependency means dependency between two non-key attributes. Here there are no non-key attributes. And one more thing, dependency between some part of the key plus some extra to non-key attributes. So here all the given attributes are non-key attributes. There will not be any transitive dependencies also. If there are no transitive dependencies, we can say that table will be in 3NF. Simply we can say that if all the attributes of the table are key attributes, then the table will be in 3NF. Now let us check if that table is in BCNF or not. If the table is in BCNF, all the right side parts of the FDs should be super keys. So if we see first attribute here XY, is one of the candidate key. So this is allowed in BCNF. With this FD, there is no problem with BCNF. Here if you see second FD, functional dependency, here right side part is Z and this is not a super key. So we can say that this violates BCNF condition. So the highest normal form is 3NF, which is option C.